The beginning of everything. So you're going to need to visit this link to watch this video, and then when you're ready, you can return here and check your work. So go ahead and navigate to this link and pause this video and go ahead and answer those questions. So, what evidence helped change scientists' minds that the universe was infinite and ageless? So, for a long time, scientists had believed that the universe was static, it was unchanging. But some new discoveries and new information started to change their minds about that. So, the theory of relativity helped us to understand gravity better. Hubble also discovered that galaxies are moving apart. We also discovered in the late 60s the cosmic background radiation. This is leftover energy from the Big Bang. And no matter where you look in space, the cosmic background radiation is very consistent. We also have improved technology and observations. So, all of these things together provided evidence that contradicted this static universe idea that the universe was ageless and infinite. So, the Big Bang wasn't an explosion. It was an expansion of space from small to large. During the quark era, what was the relationship between energy and matter? So, in the very, very early universe, less than a fraction of a second before that has passed, it was very, very hot and very, very dense. So, energy and matter were interchangeable because the temperatures were so high. So, sometimes some energy might coalesce into some matter, but because those temperatures are so hot, that's not going to be stable and it's going to break apart. So during the quark era, it's just too hot for matter to exist. Now, as the universe continues to expand and cool, eventually we enter the Nucleosynthesis Era. So nucleo here is referring to nuclear or the nucleus of an atom. And synthesis means to make. So this is the synthesis of nuclei. So during this time, temperatures were cool enough to form the simplest atom, which is hydrogen. Hydrogen has one proton and one electron. Now, this took about a second since the Big Bang to occur. So over time, all of that hydrogen gas started to clump and stick together by the force of gravity. So as that hydrogen gas is clumping together, being compressed, eventually a fusion reaction starts and we have light. Stars are starting to emit light as they fuse hydrogen together to make helium. And how does the universe experience itself? We are part of the universe. We're not separate from it. And in fact, we're really lucky because not only are we part of the universe, but we're the part of the universe that gets to think and gets to feel. We're like the universe's sensory organs. So we are how the universe experiences itself.